welcome. We are going to look at proofs today. A proof can be written out as a paragraph. So you can write a paragraph proof or what's called a two-column proof. So there are two types. There's paragraph and there's two-column proofs. There are also proofs where you do a diagram. So there's also a diagram proof. So there's three types: paragraph proof, two-column proof, and diagram proof. Diagram proofs are usually fairly confusing and don't say any more than either of the other two. So I generally just stay away from diagram proofs. I don't even show them to the class. If you want to look up diagram proofs, you can, but they're generally fairly convoluted, and I think you get everything you need from a paragraph proof or a two-column proof. So as we go on and do more complex proofs, I will show how to write a paragraph proof. However, I believe that two-column proofs are much easier. So they, again, two-column proofs say just as much as a paragraph proof, yet there's much less writing involved, and it's a little bit neater. It's a little bit easier to read, usually. So let's go ahead and look at a two-column proof. So here we have some given information. So whenever you're given information, you have to assume that that information is true. So we are assuming that D plus E equals 4F. We're assuming that. So we have to believe that that is true. And we are also assuming that E equals 2D. So we're assuming that these two things are true. Okay? What we want to do is prove that E equals 8/3 F. We don't know that yet. We can't say it is just by looking at the two equations. We need to prove it. So we're going to just make statements that we know are true. We cannot make a statement that we don't know is true. We cannot assume anything. So proofs do not assume anything except for what's given. So let's go ahead and see if we can prove this without making any assumptions other than the two given statements. So all two-column proof is we have a statement and a reason. Okay? So the first statement that I would like to make is that D plus E equals 4F. And there's a reason I believe I can say that, because it was given to us. So that is my reason. I'm also going to state that E equals 2D. That is also given to me. So that's why I can state it. So the next question would be, what could I do to one of these two equations to make something new? I'm not assuming anything. I am using algebraic rules in this case. So generally our proofs are going to be about pictures. So this is more of an algebraic one, but I think this is a good start to seeing how proofs work. So notice E equals 2D. If E equals 2D, does E equal 2D up here as well? And I would claim yes. If we are to assume E equals 2D, then it must always equal 2D. So we could rewrite equation 1 But everywhere we see E, we'll replace it with 2D because E does indeed equal 2D. So D plus E, plus E. But we're going to replace it with 2D equals 4F. Why are we able to say that? So the mathematical rule that allows us to say that. And that mathematical rule is substitution. We substituted the value of E, which was 2D, in for E. We substituted the value of E in for E. And we got 2D. That's all we did. Now I can combine like terms, and so D plus 2D is 3D equals 4F. And I need a reason. Well, I just said it, right? I combined like terms. So we could just say like terms. But we could actually make it even simpler than that. We could just say the rules of addition. We know the rules of addition and we followed them. D plus 2D is 3D. That is just following the rules of addition. So now I want to get D by itself. I want to know what D equals. I would really like to know what D equals. I know what 2D equals. It equals E. I'd like to know what 1D equals. All right, number 5. Number 5. So I'm going to divide both sides by 3 and get D equals 4/3 F. Okay? So I divided both sides by 3 to get D equals 4/3 F. 4 divided by 3 F's. Okay? And if I was able to say addition, then I could say division here. Dividing both sides by the same number. So it's the division property of equality. So the true statement or reason here is the division property of equality. So the division property of equality tells us that we can divide both sides by the same number and not harm the equation. All right, number 6. Number 6. I am going to rewrite this equation, E equals 2D, E equals 2D. So I'm going to take equation 2 and rewrite it. So I'm going to have E equals 2D. But I'm not going to write D. I'm going to write what D equals. That's called substitution. So again, I'm substitution. I substituted what the value of D was, which is 4/3 F, in 4D. So I have E equals 2 4/3 F's. 7. E equals 2 times 4 is 8 over 3 F. And that was by just simplification or multiplication. So I just multiplied through. You could even say distribution. So notice we are trying to prove E equals 8/3 F. That's what we're trying to prove. And we were able to say down here E equals 8/3 F. We have proven it. If you're able to state what you're trying to prove, and you have steps for each, a reason for each that is following the rules that you have been given, then you have proven what you're trying to prove. So, hopefully that makes sense. This is a 2-column proof. If you were to write this as a paragraph proof, you would write, I know D plus E equals 4F because it was given to me. You would write all of this down. This would be in a paragraph, in a neat paragraph with no misspellings and all that good stuff, following all of the rules of English. The next sentence would be, I know that E equals 2D because that was given to me. Therefore, I know I could say D plus 2D equals 4F. And that is true because I substituted the value of E in 4E into the first equation. I then combined like terms in using addition to get 3D equals 4F. I then divided both sides by 3 following the division property of equality to get D equals 4/3 F. Next, I substituted in the value of D, which happens to be 4/3 F, in 4D, and I got the equation E equals 2 times 4/3 F. The last thing I did was that I distributed the 2, and I got E equals 8/3 F. Therefore, I know that E does equal 8/3 F, and it is proven. So that would be a paragraph proof. Quite a bit more writing, and it needs to be in proper English and follow all those rules. And this is just a shorthand version of the paragraph proof. So I'm a huge fan of 2-column proofs. We will actually write out some paragraph proofs in the future because they are nice to at least see. But 2-column proofs are really useful. If you're to do the proof where you have the diagram, you would have this in a box and this in a box, and they'd be connected. And you'd have this in a box and this in a box, and you'd have them connected. You'd have this in a box connecting both of these to it. So it almost looked like a factor tree. So if you think about a factor tree, you'll have a box here and a box here, and this box goes into these 2 boxes. This box shares information, and then there's maybe this box, and then this box and this box go to here, and this box and this box maybe go to here, and then together they come, and here's your proof. You can see how that would be pretty convoluted. I am not a fan of that kind of proof. I don't think that it's easy to read or easy to follow. I love the 2-column proof. I think it's so easy to read and it's short. And I just have to look at the left-hand side and the right-hand side and see, do the statements match up with the reason that you've given? If so, you're good to go. If you've made some decision, like you said, E equals 8/3 in line 3, and you said, well, because it is, I know that's not a good reason. Because it is not a good reason. So these are all good reasons for algebra. So your assignment is going to be algebra based, but I think it's a good start for proofs because you can see, yeah, this must be true. So, all right, hopefully that helps, and have a wonderful day.